My name is Chris Boland. I'm a solution architect with Red Hat. Here today to talk about Red Hat Service Interconnect, which is a way of connecting applications across Kubernetes clusters, even across different hyperscalers, as well as connecting on-prem to public cloud clusters and even non-Kubernetes installations. And that's actually going to be the focus of what I want to talk about today and actually demo for you, creating a virtual application network between an edge Fedora server running in a yoga studio in my house to an Azure cluster. So let's go ahead and jump into this demo. So a lot of times when we think about connecting our public clouds to our edge devices, we think about HTTP traffic. But what I wanted to focus on today was more of a modernization scenario. And I didn't want to focus on just HTTP. I wanted to pick basically the worst legacy technology I could think of. And for me, that was Java RMI. And if you're not familiar with Java RMI, it's a very old school way of doing what we now probably would use web services for. So I will have an RMI server and an RMI registry running locally here on a Fedora instance running on a Mac Mini in my wife's yoga studio. And then we'll have a client that's accessing that RMI registry and server across the network, even though it is running locally. And then the goal for this demo is to peel out just the client. I didn't want to say from my modernization exercise, I have to fix everything. I wanted to leave the RMI server and the RMI registry in place and find out, can I just run the client in OpenShift running in a public cluster? So many times when we run on-prem applications that are talking to public cloud applications, we tend to initiate from the remote into the public cloud. And today I'm going to turn that on its head. I'm going to run the client in ARO, in OpenShift, in Azure, in the public cloud, and have that connect back into my house in the yoga studio on that Fedora server, but I'm going to do it without having to open up any special firewall rules or VPNs. So let's go ahead and jump into that demo. The first thing I want to show you is the status of the application. So I have a quote of the day object, which extends remote, as all RMI needs to do. That implementation of my quote of the day is just an array of strings, each one of which is a quote, and then a method get quote of the day, which is going to return a randomized string out of that array. I've got a quote of the day server, which I use to register my remote object into my RMI registry, and then I have an RMI client, which will every 4 seconds grab the RMI code from the registry and then call get quote of the day and print out to the log a randomized version of that quote. So I have that set up running now. My RMI server is running locally, my RMI registry is running locally, and my RMI client is running locally every 4 seconds, printing out a different quote of the day. This is my current state. This is my edge state where I want to modernize just the client application. Let's see what we can do about that. So the first thing we need to do, if I'm going to move this client into Azure, into Kubernetes, into OpenShift, is containerize it. So let's look at that. Let's take a look at that container file and see what that's like. It's pretty straightforward. We're going to use the OpenJDK from UBI8. We've got a couple jar files that we're going to copy into this container image, and then our run command there to start the image on port 1099. So let's go ahead and build this container image using Podman. All right, so we went ahead and did that successfully. Our next step is to tag the image and then push it into an image repository. We'll use Quay in this example. The reason we're pushing this into Quay is so that I can deploy this application into my OpenShift cluster running in Azure. So I'll need to first log into that OpenShift cluster. And I'll create a new project for myself. I'm going to call this project Aardvark. We'll use a config set context so that I can use my cube config to move around different clusters if I need to. And then finally, we will set a couple labels on this project, on this namespace. All right, so we've containerized our image. We've pushed it into Quay. We have logged into our cluster, and we're ready now to deploy our application. Let's take a look at that deployment.yaml before we apply it. So this is pretty straightforward. Our application has a name. We're going to have one instance of it when we run it, and it's going to pull that image we just pushed into Quay, quay.io/cbolin/RMI quote of the day client. And there's one environment variable of server host with the value of RMI server. So let's go ahead and apply this YAML file and deploy the application into OpenShift. There we go. We've created it. Let's take a look now at OpenShift and see what we've got going on. This is my OpenShift web console. I can click into my Aardvark project, newly created, take a look at my workloads. Oh no, that looks like a red circle and it looks like it just crashed. Perhaps something is going wrong with my application. Let's see what might possibly be happening. Yep, it's in an error state, probably a crash loop back off. Let's take a look at the logs and see what's going on. Well, we can see that I have an unknown host of RMI server. Why would I have an unknown host? Well, remember that RMI server is running locally in my house in a yoga studio on that Fedora on the Mac Mini. And Azure has no idea where that Fedora server is. It has no idea this yoga studio even exists. How could it possibly direct traffic from an application running in Azure in ARO into my home yoga studio with that Mac Mini and the RMI client or RMI server and registry running on it? It can't do it, and that's why we're getting this error. What we will be able to do though is use Red Hat Service Interconnect to solve this problem. And we can get this same tragic information from the command line as well. You can see we are in a crash loop back off state, and we have restarted this application 3 times. We can take a look at those logs, and there it is. That RMI server is an unknown host. OpenShift cannot find this. What can we possibly do to fix it? Our task has in fact failed successfully. All right, so first thing we're going to do is we're going to scale this application down to 0 so that it stops flapping and stops trying to start, because that's clearly never going to work. Then we're going to use Red Hat Service Interconnect to wire up my application running in Azure, which is trying to reach back into my house to find its RMI server and registry. So we're going to run in scupper init. We're going to pass in a couple variables here, or parameters. We're going to enable the console, and we'll enable flow collector so that we'll get some metrics around that as well. We take a look at our scupper status. And this is our console URL. We'll grab that for later. Now, because we're running our applications locally, we need to create a local scupper gateway. And we're going to do that with the command scupper gateway init. There's a couple different ways you can run your scupper gateway. You can do it as a type of podman, running as a podman container, which I'm going to do. You could run it as a Docker container, or you can run it as a systemd process. All right, so we've set up our gateway. We can check the status of the gateway. So there it is up and running. It's type podman. And in fact, if we do a podman PS, we can see that we are running that scupper gateway. We take a look at our OC status. So in our Aardvark project, we've got a couple applications that have been deployed. There's the Scupper router as well as the Scupper controller. And then you can see at the bottom our deployment for our RMI quote of the day has also been deployed. If we get our services, we only have our Scupper services. We didn't create a service around that RMI application. So we'll do that now. We're going to use Scupper service create to define a new Scupper service called RMI server. Then we're going to use Scupper gateway bind to attach our RMI server process to the Scupper service that we just called RMI server. We're going to actually bind it on 2 ports. So 5000 is the port for the registry and 1099 is the port that we're listening on. But we can bind both of these ports to that particular service. All right, so we have bound up our service. We can check out our gateway status. And you can see now that localhost on 1099 and localhost 5000 are now responding to RMI server on those same 2 ports. So let's check out our OC status now. So now we have a new service in OpenShift called RMI server, and it's listening on the ports that you would expect. Let's take a look at that in our OpenShift console. If we go to our networking section and we look at our services, there are our 2 Scupper services as well as that new RMI server. Notice, however, where this RMI server is pointed to. It's actually pointed at the pods for the Scupper router on both of those ports. And that's how we wire this application up from local to remote in Azure. And if we just do a listing of our services, that's exactly what we saw in the web console. So now what we're going to do, remember we deployed our client application, it started up, and then it promptly failed and went into a crash loop because it couldn't find an RMI server. We've used Scupper, Red Hat Service Interconnect, to create a new service called RMI server, and we have wired it up so that it is using the local gateway to connect to the Azure cluster. Let's go ahead and start our application and see what we get now. We'll just scale it up to 1 for the moment. So now we have scaled up our application. We can take a look back at our web console and our workloads. There we go. Our RMI server certainly looks happier now. It is up and running. We can take a look at the logs for our RMI server. And in fact, you can see that we're now getting a quote of the day every 4 seconds. Even though this is still running in Azure, it's now able to access the Mac Mini running Fedora in my yoga studio from Azure. And it couldn't do that before, and it's all through Red Hat Service Interconnect that this is in fact possible. And we can check the logs with the command line as well. Every 4 seconds, a brand new quote of the day. So this is working great. We've been able to modernize this application a little bit without changing anything running locally at all. We made no changes to the RMI server or the RMI registry. All we did was containerize that RMI client and then have it run in an OpenShift cluster in Azure, and through RMI Service Connect allow it to access those on-prem edge services that it was using prior to being containerized and deployed into OpenShift. Another thing we could do if we wanted to, we could actually scale this up to 2 replicas, because why not? You know, you can never have too many quotes of the day. So we scale it up to 2. We can look at that in our pods here for our project. And you can see we're now actually running 2 different instances of that RMI quote of the day application in Azure, and both of them successfully reaching back through Red Hat Service Interconnect to the RMI server running locally in the Yoga Studio in my house. And there's those two pods again, as well as the Red Hat Service Interconnect components, the scupper router and the scupper controller. And that concludes our demo for today.